This is number 28 from the 2016 Sycamore Math Invitational. And this is a classic conditional probability problem. And it's a situation where you know what happens at the end. And given that information, which is more information than you normally would have in a probability problem, you know that the outcome is 2 all 3 times. You want to say, well, what's the probability something else happened earlier in the situation? And that else thing is he pulled a red die. And so if I just said what's the probability he pulled the red die out of his pocket, the answer would be 1/3, because we have no more information than know that it's going to be equally likely to pull any of the dice out. So because we have this extra information, which is it's 2 all 3 times, we have to do conditional probability. And what conditional probability is, it's usually written like this: probability of A given B, and where A is what you want to happen, which is getting a red die in this case, and then B is the given. And the way that we calculate that is we say, well, what's the probability of B happening, which is getting a 2 all 3 times. And then we want to also calculate then, okay, so if it gets a 2 all 3 times, what's the probability that it was a red? Well, the way we do that is just we calculate, well, what was the probability of it being the red die and all 3 times? And so we usually call it as A intersect B, which means both of those events, the given statement and the wanted statement, it being the red die, happen at the same time. And we can just calculate these 3 probabilities. So let's start with our the probability of pulling the blue die out and getting a 2 all 3 times. Well, the probability of getting the blue is going to be 1/3. The blue one is a standard 6-sided die, so what's the probability of getting a 2 all 3 times? Well, each time you roll a standard dice, you're going to get a 1/6 chance of getting the 2 or any of the single numbers, and so it's just going to be 1/6 times 1/6 times 1/6 times 1/3, and so that's going to give us 1 over, well, 6 times 6 times 6 times 6 is 216 times 3 is going to give you 648, so something very big. For the red die, well, 1/3 of the time you're going to pull the red die out. It has a 2 on 2 of the sides, 4 on 2 of the sides, and 6 on 2 of the sides. Well, that means that, well, the probability of getting a 2 is just 1/3, 2 out of 6. And so you're going to do, for each of the 3 dice, 3 rolls, you're going to have a 1/3 chance of getting a 2. If you want to get a 2 all 3 times, it's going to give you this, which is 1 out of 81. And then finally, on the green die, well, it has a 2 on all the sides, and so the probability of getting a 2 on all 3 rolls, well, if the only option is a 2, then it's just going to be a probability of 1 each time, and so that's going to be 1/3. So this is the 3 probabilities of getting a 2 all 3 times. If all I wanted to calculate was, well, it's the probability of getting a 2 all 3 times, you would add these up. We will take the time to add them up. Notice the difference between the red and the blue is that these 6s are just multiplied by 2, and that's because that means that if I just multiply by 8, I get the 648. And then similarly, notice that these, you just need to multiply the denominators by 6 to get a common denominator, which is 216. So this is going to give you 216 over 648. So now the answer to this problem is going to be the probability of getting all 2s and a red, that goes on top, and then the probability of getting all 2s on bottom, which is going to give you 1 out of 648 plus 8 out of 648 plus 216 out of 648, which turns out to be 225 over 648. Using what we know about complex fractions, we just multiply the denominator by its reciprocal. 648s cancel. All that cancels to 1. We are left with 8 out of 225. The other thing you could have done on this is, thought about the 216 possible rolls and done it as a counting problem, but this is a nice way to do a conditional probability problem like this.